An important part of exploring a LANDFIRE model is to run it and view the results. In this short demo, I'm going to use SyncroSim software along with the STSim and LANDFIRE Veg models packages to review the standard LANDFIRE run settings, run a model, and graph the results. For this demo, I copied the central mixed grass prairie from the master LANDFIRE model library into its own library. Users can easily change model settings in STSim, but I'm going to review the standard set of LANDFIRE run settings starting on the Run Control tab. LANDFIRE models are run for 1,000 time steps and 10 iterations. Moving to the Initial Conditions tab, you can see that LANDFIRE starts its model runs with 1,000 simulation cells, representing 1,000 acres per BPS. If you are running multiple models at once and you want to use the LANDFIRE settings, multiply the number of models times 1,000 to calculate the recommended number of simulation cells. In the distribution table, the relative amount is set so that there is an equal proportion of cells in each class. The last initial condition setting is the initial TST randomize. TST stands for time since transition. This function is used in some LANDFIRE models to specify the amount of time since a fire before an alternative succession transition can occur. You will frequently find this setting used in fire-adapted ecosystems. For example, TST can control woody encroachment in a grassland or canopy closure in a pine forest. If TST is used in a model, it will be specified in the probabilistic transitions table. In this mixed grass prairie model, you can see that the alternative succession transition from late 1 closed to late 2 closed has a TST value of 12. In other words, a grass-dominated state that goes 12 years without fire will transition to a shrub-dominated state. Now back to the TST randomized setting. When TST is used, the initial TST Max is set to the maximum TST Min for the BPS, and you look that value up in the probabilistic transitions table. Next, we'll review the Output Options tab. State class results are output every time step and include 0 values is checked. This means that we'll get results for every state at every time step, even if the area occupied by a state is 0. Transitions are output every 500 time steps and calculate as interval mean values is checked. This allows us to discard the first 500 time steps when the model is reaching equilibrium and calculate results for the last 500 time steps of the simulation. The final setting used by LANDFIRE, found on the Advanced tab, is the time since transition group. For LANDFIRE, TST is associated with the transition type alternative succession, and for the transition group all fire, which includes surface, mixed, and replacement severity fire transitions. Once the settings are attributed, save the model. Make sure that you select the scenario you want to run, then click the Run button. I've already created 2 graphs to show how LANDFIRE calculates reference conditions for the amount of each state in a BPS and the average fire frequency. If you are starting from scratch, make sure your results are part of the active results scenario by right-clicking on the results and selecting Add to Results. On the Charts tab, click the new chart icon. Name the chart and click OK. I'm going to go back to the chart interface and open up the state class graph I've already created. On the left side, you can see the graphing options I selected, including the 3 state classes that make up this BPS. On the right, you can see how the amount of each state class varied over time. Notice that each state starts with 1/3 of the simulation cells, then stabilizes over time. You can switch from line chart to column chart to get an estimate of the final state class proportions. Now let's go into the fire frequency chart. Again, you can review the graphing options on the left. On the right, you can see the results for surface, mixed, and replacement fire, as well as for all fires combined. The graphs show the average fire proportion for the first half and the last half of the simulation. LANDFIRE takes its fire frequency results from the last 500 time steps when the model has stabilized. By hovering over the blue line, you can see the average proportion of fire for the interval. In this case, the replacement fire proportion is 0.21, which is equivalent to about a 5-year fire return interval. Changing run settings and graphing model results is a great way to explore and understand a LANDFIRE BPS model.